So good day everyone, you're welcome back to the channel Learners. Today we're going to be looking at a special situation with differentiation, right? Now if you're given a function of this nature, y equal to square root of x, and you're asked to differentiate this using first principle, what do you do? How do you go about solving that? Now differentiating this function y equal to square root of x using the general form of differentiation, this is the answer we should be expecting, right? So I'm going to rewrite this as y equal to x raised by 1 over 2, right? Then I differentiate this as dy dx by multiplying the coefficient of x with the power of x, right? So that's going to be 1 over 2x, then raised to power 1 over 2 minus 1, right? You reduce the power by 1, and what do you get? What do you get after reducing the power by 1? You're going to have 1 over 2x raised to power negative half, right? Okay, so I'm going to rewrite this as 1 over 2. Okay, the power of x here happens to be negative, so I'm going to bring x down to be attached to the the denominator of this fraction, right? So x is going to now have a positive power of 1 over 2, right? Which I can then express as this 1 over 2 root x, right? So this should be the differential we're expecting if we use first principle, right? So how do we go about using first principle? Now this function we are given, this is f of x, right? F of x is equal to square root of x. That's the function we're given to differentiate. Now if I'm to add the change of x to form a new function, I'm going to be writing that as f of x plus change in x, right? That's x with its change. Now that's going to be the square root of x and its change, right? So this function is that of f of x, and this is that of f of x plus change in x. And if you recall, you remember that the formula, or the principle rather, we use for differentiating the first principle is given by this expression, right? That's dy dx, or you can put it as change in y over change in x, is actually equal to the limit as change in x approaches 0 of this expression, f of x plus change in x minus f of x, right? You remember this, right? Divided by change in x. Now this is a principle we apply when using first principle, right? So we're going to try to apply this to differentiate this function and see if we arrive at the same answer, right? So how do we get f of x plus change in x minus f of x? These are the two functions, right? We're going to be subtracting this from this, right? Subtracting f of x from f of x plus change in x. So this right here is going to be, what do we have as f of x plus change in x? That's square root of x plus change in x, right? Then we have the minus sign, the negative sign, and we have f of x here, and that's just square root of x, right? Everything is going to be divided by change in x. Okay, we're actually going to take the limit of this at the end of the day. Okay. All right. So the next step we're going to take from here is this. This, our expression in the bracket, is now looking like a sword, right? Due to the presence of the square root signs in both terms, it's now looking like a sword. So I'm going to try to rationalize this to see if I can simplify further, right? Rationalizing this, I'm going to multiply the expression in this bracket with its conjugates, right? And the conjugate of this is going to be square root of x plus change in x plus square root of x, right? Divided by the same conjugate, x plus change in x plus square root of x. That's how we rationalize swords, right? Now, how did I get this conjugate? I just did that by changing the sign between the two expressions here, the two terms here, right? The sign was negative. To get the conjugate, I just had to change it to positive, right? So if this were to be positive sign, the conjugate will have a negative sign, right? Alright, so let's carry out this multiplication and see the way forward, right? So this is going to be, I'm going to multiply this with this. That's going to be square root of x plus change in x all squared, right? Since it's the same term multiplying itself, that's going to have a square sign now attached to it. Right now, this multiplying this is going to be applying the law of multiplication for such, right? I'm going to be multiplying these two terms in just one square root sign, right? So x is going to be multiplying x plus change in x in one square root sign, since they are both having square root signs there, right? So after multiplying this with this, I'm going to have to multiply this now, that's negative square root of x, with this first term here, right? So we're going to still apply that multiplication law for such, right? By multiplying this and this in one square root sign. So x is going to be multiplying x plus change in x in one square root sign. Now finally, I'll be multiplying the square root of x with the square root of x. There's a negative sign here. So that's going to be the square root of x squared, right? Since square root of x is multiplying square root of x, we're going to have square root of x squared. Alright, then for the denominator, we're going to have change in x multiplying the square root of x plus change in x plus square root of x, right? This is going to be multiplying this. You can decide to open this bracket if you want, but let's just simplify the numerator. Let's simplify the numerator. Alright, for this numerator, we're going to, okay, you notice that this cancels this out, right? Since we're having square root of x subtracting this, so this is going to cancel out. And this square is going to cancel this square root. This as well is going to cancel this square root. So what are we left with? We're left with the limit as change in x approaches 0 of what? Now, we have x plus change in x here, right? After cancelling the square roots. Then we have x here, negative. There's negative sign, negative x, right? That's what's left of the numerator. Okay. Then at the denominator, we have change in x. There might be no need to open this bracket, right? X plus change in x plus square root of x, right? Alright, back to the numerator, we have x plus change in x minus x. Now this x can actually minus this x, leaving us with change in x, right? So I'm going to rewrite this as the limit as changing x approaches 0. Now we're left with change in x in the numerator. Then the denominator, we have change in x multiplying the square root of x plus change in x plus square root of x, right? Since we didn't, okay, that's not a problem. We didn't actually open this bracket. It's going to be easier now to cancel change in x with change in x, right? So we're going to be left with the limit as change in x approaches 0 of 1, right? There's nothing that just cancel this, so we're left with 1. Then for the denominator, we're going to have x plus change in x plus square root of x, right? Alright, I think that's how far we can go with the simplification. There's no further simplification we can carry out here, so let's just proceed with taking the limits and see what our answer is going to be like, right? So I'm going to take the limit of this expression as change in x approaches 0, right? And I'm going to do that by direct substitution. I'm going to be substituting change in x for 0, right? Wherever you find change in x in your expression, you just substitute 0 for that, right? So what are we going to have? We're going to have, okay, this is actually changing y over changing x. That's what we've been finding all through, right? We're trying to differentiate this. We're actually finding dy dx. So what's dy dx going to be? Dy dx is going to be equal to, now we want to take the limits of this expression. Okay, 1 over square root of x plus, now this is changing x, right? Dy dx equal to, okay, dy dx equal to 1 over square root of x plus change in x plus square root of x. Now you're going to substitute this with 0, right? It's taking the limit as this approaches 0. So you replace this with 0. You understand? Alright, so having replaced that with 0, what are we going to have? What's the expression now going to look like? Now this is going to be square root of x plus 0. And what's x plus 0? That's x, right? So this is going to be x plus, then this is also the square root of x, right? Now for the denominator, as you can see, we have 2 square root of x at the denominator. So square root of x plus square root of x, that's going to be a total of 2 square root of x, right? So this is going to be the final answer for dy dx. So I see how long it's going to be if you apply first principle. By the end of the day, you get the same answer. And that's correct, right? Alright, so hope you understood this video, you understood everything I explained, right? Goodbye.